how the AI or machine learning can employ in the customer company. One of the classic example, I agree with Dr. Kaplan, is recommendation. We can make recommendation based on certain or similarity of attributes. Say a gender, male, age of 20 to 25, used to look into a book of about the car, save in Amazon. So if somebody log in into Amazon and his profile says he's a male with a certain range of age, then Amazon can also give him a recommendation about the product. And also based on the history, so for instance, somebody usually in the past month or past year looking for a book about, I don't know, about machine learning, about big data, then next time he login into the Amazon system, he will also, the Amazon will give him about recommendation. That's one example. Another example is association. From a bunch of data, it can employ a data mining to make association. Association means to find connection between data. So for instance, if people goes to, I don't know, Indomaret or Carrefour, if people buy a tissue, usually they will buy baby nappies, and then they will buy milk, for instance, mined from the data. So then the shop can arrange those items in the near place. So in order for, for customer to make it easy for them to find the item, and okay, then they will spend more time to buy another item. So that's two classic example of how the artificial intelligence or machine learning can be employed. Thanks.
Yeah, Mr. Edi, would you like to add something? No? Thank you. Any other comments or questions? Audience, please. Yeah, there are two. Come to you first.
Dr. Kavana, thank you for the explaining AI and big data to some of us laymen's out here. Appreciate that. My question is around AI. Could AI be stuck in a self-fulfilling prophecy? So let's say it learned something, it's done it before, and it continues to go and does it again. And how do you get it to evolve to doing something different or trying something different? Do you understand my question?
Yes. I mean, for someone that just mentioned layman terms, what you've described there is actually a very famous problem in AI, and it's called being stuck in a local minima for the system. Meaning that if we have a curve, or the way we describe it, us geeks, if you have a curve and you have an AI system whereby the optimization problem is to reach the tip of the curve, then you get stuck in a part of the curve that looks like a minimum part, but the system cannot improve further because of the limitation of its membership function that would lead it up there. We usually solve it by literally shaking up the system. And I'll give you an example here. For example, a very typical AI model that we use is called a genetic algorithm. Now, a genetic algorithm is very simply a system that tries to mimic the process of evolution. Meaning, we have parents, moms and dads, they marry, they have babies, and then the cycle of life goes on. It's exactly the same. We start with a problem that we try to solve, a problem that does not have a mathematical solution to solve it. So we start with a population of random solutions, 100 solutions, the moms and the dads. So we split it in half, 50 and 50. These solutions, by the way, are nothing but ones and zeros. And then we marry these solutions to produce an offspring. The offspring, or the baby, is half of each mom and half of each dad put together. But then we apply a process, this is called crossover, and the process keeps on getting repeated, meaning that we keep on comparing the offspring from a mathematical solution perspective to the parents. And if any of these offspring are actually solving the problem or are closer to solving the problem, then it's called natural selection, survival of the fittest. They would replace the parents. And that is called one iteration. Every iteration is called a generation. So we keep on applying that loop and we produce many generations. So each generation we compare the children to the parents. If there are better solutions, they replace them. You repeat it for 1,000 times, 1,000 generations. However, that's when the system usually gets stuck in a local minima. So we add something that's also inspired by the Darwinian process of evolution, which is called mutation. So we add a process with a very low probability of almost 0.01% of happening, but it happens if you apply it to a million generations. It might happen. And if you mutate the system and you get one of these 100 children that is mutated, but instead of being stuck in the curve down here, it will be somewhere in the middle towards the global maxima that we're trying to reach, then that child will have a higher likelihood to reproduce other children that are much closer to the solution, and as the generations come, we'll be able to reach that peak. So that is a very typical way for us to mitigate these problems of learning the wrong way and keep on doing it again and again and again and again. Fantastic question.
Thank you. Somebody there? Yes, please.
Thank you. My name is Adrian. I'm focusing in two industry now. The first one is the healthiness or medical devices, and second is the small medium enterprises. During my working with all these two industries, I was in FMCG background. The challenge is now the data is the key, everyone say. But understanding the data, okay, data is a king now. It's not a cash anymore, yeah? Data is a king, but understanding data is a King Kong, people say, because so many data that we have. It might become the source of the brainstorming or the source of we can work together if how the user, let's say in the small medium enterprises, they're seeing the data is the things like the expensive one. We have to connect it with the SE Nielsen. We have to connect it with all the consultants team, yeah? So how to bridging? I know this is especially with from you, Mr. Kaplan, that all these things that you explained, it happened in the grassroots now. So many Indonesia companies, small company, can produce anything. Indonesia can produce anything, but once they already have a product, they get confused to whom I have to sell, which is the route should be backward. Number one is to whom I have to produce, then we start the backward process. That is the Indonesian current situation now that maybe we can bridging that. So is that any institution or any, like Pak Tri said, is that any initiate can bridging these needs for Indonesia, small medium enterprise or other local company, to utilizing this advantage, especially in the AI? That's my question. Thank you.
Thank you. Very good question. I think I should start from Mr. Kaplan to answer the question.
I totally agree. I mean, and it's a very important thing to address. As I started earlier, I said when it comes to data, we should go, or our aim should go through these 5 processes of starting with the data, processing the data, we have information. From information we get knowledge. After acquiring knowledge, we have to form an understanding, and the holy grail or the final end result should be achieving wisdom or being wise enough to understand how to start all over again and get the new data and achieve wisdom. Like you rightly pointed out, the most important part should be in understanding how to utilize the data that we already have at the process of starting to develop the product. It is, in my opinion, a good problem to have, because it means that we have already started with the most important thing, which is trying to develop a product, which is usually the harder part. But once we understand what product we want to develop, and we know that we have the data sets, I mean, there are many methodologies such as the ones I've described throughout this panel, especially the ones that we're employing at SixCap, which is extracting the valuable insights from data, performing pattern recognition, digging deeper inside this data to understand the interlinks between the various entities within the data sets. I must stress here that we really have to move from the traditional relational database model to more relational elastic database model, because we have to move from a structured form of data analysis to unstructured data sets, because the data that we are generating now at a very high pace is not necessarily data that is related. So when people speak about big data in general, they should actually be speaking more about linked data and data that has interlinks or linear data that is much easier to deal with and much easier to process and analyze and filter, as I said. However, it would be a very interesting exercise even for us at SixCap to understand the different needs that there are out there. Like Dr. Widi mentioned earlier, one of the things that we're looking at is helping with the transport situation in Indonesia. There are some very valuable data sets out there. A lot of data has been generated that is waiting to be mined out there to actually identify all these behavioral patterns within these data sets and get the valuable insights from them, and being able to develop systems around them that will optimize the transport infrastructure throughout the entire country. So please, if there are any generic domains out there, I would be very happy to speak about them after that.
Thank you. Yes, Dr. Trikuntara.
I'd like to add last comment. It is true that actually what we need about big data is should be facilitated by the high-speed computation and high-end computation power. And then the innovation, it should be that there is no single entity who develop the such parallel computer. It means that it should be a collaboration network between institutions, so the power can be distributed, so and the data also can be put in the cloud, so we can solve the weather problem, weather prediction problem, also drug design, bioinformatics, and so on, where this is in the year of 1999, it has been tried to develop the worldwide network of the high computation power. So actually this is for initiate again to recall that we need the computation power that we can handle ourselves and we can develop ourselves. So I agree with the last statement that actually if there is any data can be shared, so actually we can work together to analyze and then to develop the AI system and to solve what I call national problem. I think that's all. Thank you.
Thank you. Thank you very much. So, if I may conclude shortly that we are come into the change of new paradigm of logical thinking, so that with the availability of big data analytics, AI, there are changing in approaching a certain a problem in order to get a better result through knowing the way of thinking of a certain population, so that sharper result, better result, quicker result can be achieved, and also of course this will help everyone to solve their problem. Thank you very much. Let's give applause to all of the speakers here. And thank you. And let me give back the time to coordinator, please.
Yeah. Thank
Yes,
you,
sorry.
Dr. Pari. It was a wonderful session. I just would like to know that while we have quite a room full of people, we are live streaming from this conference, and we are also engaging about 100,000 people outside on our social media campaign and reaching almost 1 million. So what you say today, the panel, is very critical to reaching a broader segment of Indonesian society, and I think that's very critical as we try and reach and engage with the Indonesian community. I have some tokens of appreciation for the panel for joining us this morning. I'll just go by the panel first. Terima kasih, Pak.
Tri Kuntoro,
Yes.
Toro,
Yes.
Wihana, Professor Wihana,
Yes, that's true.
Dr. Kablan,
Dr. Kaplan, I'm sorry, I don't have one.
Oh.
Dr. Kuman, yeah. Dr. Eddie,
Thank you very much.
and Dr. Widiawan.
To the one.
Thank you.
Thank you. There we go.
Oh, finally. Thank you. Now I can sleep. Thank you.
Thank you. And Dr.
Oh,
Pari
yeah.
juga.
So,
Thank you very much.
thank you very much.
Please
Bye-bye.
join me in thanking our panel and of course our wonderful moderator.